Now you know what sig figs are, but what are you going to do with them? Well, as you guys might remember from your sophomore, junior years in chemistry, you do a lot of math. And so that's where your sig figs are really going to kick in. Every single time you do a math problem, you're going to use significant figures. So there's one set of rules for addition and subtraction, one set of rules for multiplication and division. You'll honestly use the multiplication division one much more than the addition subtraction one, but you do need to know how to do both. For addition and subtraction, you're going to type the numbers in your calculator like you always would, and then you're going to find the original measurement that you took that's the least precise. So in other words, you're going to look for the one that has the least number of decimal places. And then you're going to round your answer to the same column as the least precise measurement, the one with the least number of decimal places. So you'll notice I didn't mention sig figs at all for doing addition and subtraction problems. So here's an example. What if you had, for example, I don't know, you measured out a certain amount of powder in a little dish, and you knew that the powder plus the dish was 19.06 grams, but the dish by itself was 4.1 grams, and you wanted to know the mass of just the powder. Well, you'd have to subtract out the dish, right? Well, apparently we used different measuring tools when we got this measurement than when we did this measurement, because the 19.06 has 2 decimal places where the 4.1 only has 1 decimal place. All measurements include a guessed digit, and so this first measurement, they're guessing on the hundredths place, and then the second one, they're guessing on the tenths place. It's not as good of a scale. So when you type in your calculator 19.06 minus 4.1, you would get an answer of 14.96 grams. The problem is when you got that answer, you only knew this one to the tenth place. So how does your answer have a hundredth place? You're overstating what you actually know. So because this first value had 2 decimal places, this one only has 1 decimal place. 1 decimal place is a worse measurement, so I'm going to only keep 1 decimal place. I'm going to chop it between the 9 and the 6. Then you're going to follow your, third grade rounding rules, where you're going to look behind that chopping block. If the number behind the chopping block is a 5 and up, it's going to give the number ahead of it a little nudge. So this 6 nudges that 9 and turns it into a 10. Well, that turns into a double bump situation. So we wouldn't just write down 15. We were trying to keep 1 decimal place to match the 1 decimal place of our 4.1 gram measurement. So I'm going to write down 15.0 grams. You should be comfortable taking numbers in and out of scientific notation in this class. When you do, if you are asked to ever take measurements, put them in and out of scientific notation, just make sure that your sig figs stay the same between your standard format answer and your scientific notation answer. So this guy has 3 sig figs. That's a right 0 there. And so if I were to take this guy and put it in scientific notation, I want to keep 3 sig figs. So I wouldn't just write 1.5 times 10 to the first. I'm going to write 1.50 times 10 to the first. So that way I can keep my 3 sig figs. If you're doing multiplication and division, that's really where the sig fig thing kicks in. You're going to do your math like always, type your numbers in your calculator, count the number of sig figs in your original measurements, and then round your answer to make it have the same number of sig figs as your measurement with your worst number of sig figs, your worst measurement. So let's say you were trying to get the volume of a box and you took 3 dimensions. The length is 2.08 meters, the width 13.82 meters, length, width, height, and the height's 18 meters. Well, you can clearly see we must have used a different measuring tool for that 18 meters because there are no decimal places to that measurement at all. That tells me that the last measurement's somewhere between 17 and 19, where the first measurement, for example, is somewhere between 2.07 and 2.09, much more precise, right? So that 2.08, the 2 and the 8 count, this 0 is in a sandwich. It also follows the right rule. So this guy has 3 sig figs. The 13.82, anything that's not a 0 counts. So this guy has 4, 2. So you're going to throw it in your calculator like you always do, and your calculator will tell you that the volume of that box is 517.4208 meters cubed, right? Meters times meters times meters. That's what your calculator says. But your calculator doesn't know your measurements have some error associated with them. So our worst measurement only had 2 sig figs, so I'm going to keep 2 sig figs. Now it's 2 sig figs, not 2 decimal places. So I'm going to keep this one and then chop it. Now the most common wrong answer that I see people write down is 52 cubic meters. So if that's what you were thinking, you're in good company. The problem with that is that you're rounding the number 517.4208. 517 is nowhere close to 52, but it is close to 520. That still has 2 sig figs like we want because that 0 is not a right 0. It's not in a sandwich. So our sig figs have been preserved. So our sig fig answer, we have 2 sig figs in that 520. If I wanted to take that guy and put it in scientific notation, I want to keep it with 2 sig figs. So I'm going to say 5.2 times 10 to the second, not 5.20 times 10 to the second, because 5.20 would have 3 sig figs. What if we're trying to get the density of an object? This object's really light. It's got a mass of 0.00348 grams, but it occupies 129 milliliters worth of space. So first thing you would do, throw that guy in your calculator and see what your calculator spits out. And it would give you 0.0002696, and then a few more numbers, grams per milliliter. But now we have to round. So the 129 has 3 sig figs, the 1, the 2, the 9 all count. For that 0.00348, this one does not count, not in a sandwich to the left of the decimal. The next 2 zeros fulfill half of the right rule. They're to the right of the decimal, but they're not to the right of anything significant. So these guys do not count. So it's just the 3, the 4, and the 8. So this guy also has 3 sig figs. So we want to take our answer and make it have 3 sig figs. Not 3 decimal places, 3 sig figs. The most common wrong answer I see people do is they say, okay, 3, 1, 2, 3. Well, we haven't written down any sig figs yet, right? There's no sandwich, there's no right rule. We have to go to where the sig figs are. So the first sig fig isn't until the 2. Okay, so behind my chopping block is a 7. That's going to give this 9 a nudge, turn it into a 10, so we have a double bump. So this would be a situation where we'd have 0.00, So we have our 3 sig figs. If we wanted to put that in scientific notation, I want to make sure it has 3 sig figs. So I'm going to say 2.70, not just 2.7, times 10 to the negative 5th. And we always want to make sure we have units. So our answers would say grams per milliliter.